Okay, you are given a series, a Maclaurin series, so it's centered at 0. It gives you the sigma notation and it gives you the expanded notation as well. First question is we want the interval of convergence. So remember, for interval convergence, either we can use the idea that it's a geometric series, and if I look at this series, it is not a geometric because that n plus 1 on the bottom. So we're going to have to go to the ratio test. Oops. So ratio test says that we're going to take the limit of that n plus first term divided by the nth term. So that's the same as multiplying by the reciprocal. So there's my setup. Now I'm going to simplify a couple things first. So remember we talked about this. Really, this is really 2x to the n times 2x to the second. So this would really be 2x to the n times 2x to the first. So the 2x to the n's will simplify, and then one of the 2x's. So really all you're left with is a 2x on the top. And then you still have the n plus 1 and the n plus 2, right? We can't cancel those yet. But now when I take the limit as n goes to infinity, notice the degree is the same, so the limit is just 2x. So the limit, so you want to make sure that you show your setup, which is this, and then you want to show your limit, which is the absolute value of 2x. And we know for a ratio test, it converges only if that limit is less than 1. And we can go ahead and solve this pretty easily, so we're going to get to here. Now, they are asking for the interval of convergence, and the ratio test is inconclusive at those endpoints, so we're going to go ahead and need to check those endpoints individually. So I'm going to start with x equals 1/2. So what I'm going to do is I'm going to take that and plug it back into the original series, because I want to know what happens when x is 1/2. And when I do that, I end up with 2 times 1/2, which is just 1. And I end up with this. But 1 to the n plus 1 is really the same as 1, so I can just write it like this. Okay, now there are a couple ways that you can figure out what happens to this series. You can either do the integral test, or you can do the limit comparison test. I'm going to go ahead and do the limit comparison test. I can see that I can compare it to 1 over n, which is a p series that I know that diverges. And if I do the limit comparison test, oops, it's the original divided by what you're comparing it to. And remember, limit comparison test says if you get to any positive real number, then the original series will do the same thing as what you are comparing it to. So I know by the limit comparison test, this also diverges. So that means at 1/2, we are not going to include it. Let's see what happens at negative 1/2. So at x equals negative 1/2, I'm going to do the same thing. I'm going to go back to the original series, but notice if I plug in negative 1/2 for x, 2 times negative 1/2 is negative 1. So I end up with this. So this is an alternating series. And remember, we talked about if you have an alternating series and all you have is n's in the bottom, I know this is going to converge. Oops. So it's going to converge by the alternating series test, because I know the absolute value of the numbers will decrease to 0. So I'm just going to write it out like this. So that means that your interval of convergence, you want to include the negative 1/2, so bracket, but not include the 1/2, so parentheses there. So that's part 8, dealing with interval of convergence. Okay, delete this, and let's look at the next part. Part B says, find the first 4 terms and the general term for f prime. So this is f. So in order to get to f prime, I'm just going to go ahead and take the derivative. So the derivative of the first term, 2x, is just 2. Derivative of the next term, 4x squared, is 8x divided by 2. Then keep going. 64x cubed over 4 plus dot, dot, dot. Notice it wants the first 4 terms. Okay, I'm going to simplify this a little bit, and notice what happens. There's my first 4 terms, And notice I can write the general term pretty easily. Notice 2, 4, 8, 16, those are your powers of 2. So really you have 2 to the n plus 1. If I make n start at 0, that will give you 2 to the first, then 2 to the second. And then I need it to be x to the n, because you want your first term to be x to the 0. So that would be your general term plus dot, dot, dot. And then lastly, part C says, use the series in part B to find the exact value of f prime of negative 1/3. So they want you to plug in negative 1/3 for x and figure out what this is if I add this up infinitely. Well, if you look at this series, what we should recognize is that this is a geometric series. So the sum of a geometric series is going to be a over 1 minus, notice your r is actually negative 2/3 because you're multiplying by 2 and the negative 1/3. So this is your sum, and if I simplify it, I get to 6/5.